Hi everyone, welcome to Education World. In this video, we will be discussing data analysis using Pandas in Python. Before talking about Pandas, one must understand the concept of Numpy arrays. If you do not know what is Numpy, go to my previous video tutorial about Numpy. I have given the link in description below. Why we need to know Numpy? Because Pandas is an open-source software library which is built on top of Numpy. Pandas is an open-source, BSD-licensed Python library providing high-performance, easy-to-use data structures and data analysis tools for the Python programming language. Python with Pandas is used in a wide range of fields including academic and commercial domains including finance, economics, statistics, analytics, etc. In this tutorial, we will learn the various features of Python Pandas and how to use them in practice. Pandas is an open-source Python library providing high-performance data manipulation and analysis tool using its powerful data structures. The name Pandas is derived from the word panel data and econometrics from multi-dimensional data. In 2008, developers McKinney started developing Pandas when in need of high-performance, flexible tool for analysis. Prior to Pandas, Python was majorly used for data munging and preparation. It had very little contribution towards data analysis. Pandas solved this problem. Using Pandas, we can accomplish 5 typical steps in the processing and analysis of data, regardless of the origin of data: load, prepare, manipulate, model, and analyze. Python with Pandas is used in a wide range of fields including academic and commercial domains including finance, economics, statistics, analytics. Domains including finance, economics, statistics, analytics. Key features of Pandas: fast and efficient data frame object with default and customized indexing. Tools for loading data into in-memory data objects from different file formats. Data alignment and integrated handling of missing data. Reshaping and pivoting of datasets. Label-based slicing, indexing and subsetting of large data sets. Columns from a data structure can be deleted or inserted. Group by data for aggregation and transformations. High performance merging and joining of data. Time series functionality. Time series functionality. Let's check how to install Pandas. To install Python Pandas, go to your command line /terminal and type pip install pandas, or else, if you have Anaconda installed in your system, just type in conda install pandas. Once the installation is completed, simply import it by typing import pandas. Pandas deals with the 3 data structures: series, data frame, panel. These data structures are built on top of Numpy array, which means they are fast, dimension and description. The best way to think of these data structures is that the higher dimensional data structure is a container of its lower dimensional data structure. For example, data frame is a container of series, panel is a container of data frame. Series, 1D labeled homogeneous array, size is immutable. Data frames, general 2D labeled, size mutable tabular structure with potentially heterogeneously typed columns. Panel, general 3D labeled, size mutable array. Building and handling 2 or more dimensional arrays is a tedious task. Burden is placed on the user to consider the orientation of the dataset when writing functions. For example, with tabular data frame, it is more semantically helpful to think of the index, the rows, and the columns rather than axis 0 and axis 1. Mutability. All Pandas data structures are value mutable and can be changed, and except series all are size mutable. Series is size immutable. Series is size immutable. Series is a one-dimensional array-like structure with homogeneous data. For example, the following series is a collection of integers 10, 23, 56, 17, 52, 61, 73, 90, 26, 72. Series can be handle homogeneous data, size is immutable and values of data mutable. Series is a one-dimensional labeled array capable of holding data of any type like integer, string, float, Python objects. The axis labels are collectively called index. A pandas series can be created using the pandas.series constructor with data, index, type, copy as the parameter. Whereas, data takes various forms like n-dimensional array, list, constants. Index values must be unique and hashable, same length as data. Default np.arrange_n if no index is passed. Type is for data type. If none, data type will be inferred. Copy data. Default false. A series can be created using various inputs like .array, dict, scalar value or, let's perform it practically. A basic series, which can be created is an empty series. Import the pandas library and aliasing as pd. Initializing series with pd.series and print s. Let's create a series from n-dimensional array. If data is an array, then index passed must be of the same length. If you do not pass the index, then by default it takes index range equal to the array length. For example, import pandas and Numpy libraries, then initialized an array with a, b, c, d as elements, and convert this array to series with pd.series. Let's print this series s and check the output. So by default, it assigned the indexes ranging from 0 to length of data -1. It is 0 to 3. Let's create series with index. We pass the index values here as 100,101,102,103. Now we can see the customized indexed values in the output. Let's create a series from dictionary. We can pass a dict as input in series, and if no index is specified, then the dictionary keys are taken in a sorted order to construct index. Let's check this by the example. Import pandas and Numpy libraries, then initialize a dictionary, and convert this array to series with pd.series. Let's print this series s and check the output. If index is passed, the values in data corresponding to the labels in the index will be pulled out. Check this in example. Index order is persisted and the missing element is filled with now not a number. Let's create a series from scalar. If data is a scalar value, an index must be provided. The value will be repeated to match the length of index. Let's check this by the example. Import pandas and Numpy libraries, then initialize the series 5 index values, and print the series s and check the output. Now check how to access data from series with position. Data in the series can be accessed similar to that in an ND array. Retrieve the first element. As we already know, the counting starts from 0 for the array, which means the first element is stored at 0th position and so on. Retrieve the first element. Retrieve the first 3 elements in the series. If A is inserted in front of it, all items from that index onwards will be extracted. If 2 parameters is used, items between the 2 indexes, not including the stop index. Retrieve the first 3 element. Retrieve the last 3 element. Retrieve data using label or index. A series is like a fixed-size dictionary in that you can get and set values by index label. Retrieve a single element using index label value. Retrieve multiple elements using a list of index label values. If a label is not contained, an exception is raised. I have explained the introduction of Pandas library and series data structure. I will explain the other two data structures, data frame and panel, in the next video. Keep practicing and subscribe this channel.